Hi guys, welcome back to my channel. Today we'll be going through question 16 onwards. This is for the paper January 2019 Edexcel paper 1. So let's start. Okay, so this question we want to rationalize the denominator. So basically we want to make this part. Okay, we want to remove the square root away. So to do that, we have to multiply this. Okay, so this minus and plus. So we have to multiply it together to get rid of the square root for b. So I've talked about this in my previous videos on the rationalization of denominator. Okay, so let's just look at the workings for now. When you multiply it, it becomes like this, correct? So be really slow and careful. So what we do is a multiplied by a plus square root 4b, and then square root 4b multiplied by a plus square root 4b. Okay. Similarly, a plus square root 4b minus square root 4b, a plus square root 4b. Okay. Simple expansion. We get this. Okay, so be really careful. A times a square, a times 4 square root 4b, square root 4b, a square root 4b, and then square root 4b multiplied by square root 4b, we get 4b. Okay, the bottom part, a times a square, a times square root 4b, a times square root 4b, minus square root 4b times a, we get minus a square root 4b, then minus 4b. Okay, because square root 4b, square root 4b minus, then we get minus 4b. Okay, then you realize that this cancels out, so we're left with a squared minus 4b at the bottom, and then on the top, a square root 4b plus a square root 4b gives us 2a square root 4b. So this is our final answer. Okay, let's move to the next question. So this one here, basically we want to, given this equation here, we want to find m. So what we can do is that we can simplify this one, okay, such that we get x over y to the power of m. Okay, so let's see. So I rewrote this. So what can we do? If I take the square root out, then it will be 5 over 2, right? And then because there's this minus sign here, so what happens is that I can swap x over y, and I remove the minus sign. So as you can see, x is to the power of 5 over 2, and y is to the power of 5 over 2. So therefore, m is equals to 5 over 2 equals to 2.5. Okay, so let's continue. So this question here, we want to calculate the value of x. So, oh, this looks, slightly confusing because we have this angle here. We're given 110, 4.1 centimeter, and 5.3 centimeters. So immediately you should see that we sort of need to use something like sine rule, cosine rule, right? So we can't use sine rule because we only got one angle here. We don't have two angles because remember sine rule, we need two angles. Okay, so what we're left with, cosine rule. So to use cosine rule, what can we find with cosine rule, and what can we use to find so you sort of see that we got AC here that we don't know, right? So we can use cosine rule. Okay, so if we write cosine rule, it's AC square okay, equals to AB plus BC, okay, minus 2AB times BC cosine ABC. So it's always this angle in the middle, okay, between this orange and green line. Okay, AB and BC is always this angle in the middle. Okay, this is how the cosine rule formula works. Okay, so with this, you fill in the numbers. So you know AB is 4.1, BC is 5.3. Okay, and then you know that ABC is 110. So source it. Square root, because we're going to get rid of this square here. Then we get this. Okay, not exactly this dot, dot, dot. Okay, then we got AC now, but so AC is 7.7307 dot, dot, dot. So we got AC now, but our aim is to find X. So you can see that the opposite angle, the opposite length is 5.3, and then the opposite length for 110 is this. So we can use sine rule, can't we? So we'll use sine rule, which is this. So sine x over 5.3, so sine x over 5.3, sine 110 over AC. Okay, so this gives us, we cross multiply this over, so we get this. Okay, then inverse sine, put this into a calculator, then you get your answer 40.1. So this is like a sort of not so difficult question as compared to the previous volume hemisphere question. I expect some students to have a little bit of careless mistakes here and there, but overall it's doable, and for those capable one, you should get full marks for this. All right. Okay, next question, 18. So this question asks us to sketch the graph where y equals to f half x, right? So you can see that the x or the x value, right, has become, instead of x, it has become half x. So from this, you should see that it is a shrink. The curve shrinks. Okay, it becomes smaller, right? Okay, so you can see that from this point it moved up to this point. So from instead of -4, it's 3 now. Okay, then instead of 3, it becomes 2. Instead of 5, instead of 4, it becomes 3. Okay, instead of -2, it becomes -1. Okay, so you can see that there's a decrease. Okay, so this is the sketch for y equals f bracket half x. Okay, then for our next one, we want to find the value of k. So x plus k is a translation. Okay, so as you can see, I've drawn the original curve. Okay, this black curve here in blue. Okay, and you can see that this curve has moved to the right by 3 units. Okay, this point here has moved to this point here by 3 units. Okay, this point here has moved here by 3 units. So k is equal to 3 because it has moved 3 units to the left. Okay. Okay, so next question, 19. Okay, so for this, we want to find the range of G inverse. So remember this, okay? The domain of G is equals to the range of G inverse. So therefore, since we're given the domain of G, which is x bigger equals to -3, so therefore the range is this. Also, this, you can memorize this as well. Domain of G inverse is equals to a range of G inverse. So you can memorize this as well. Okay, then now we want to express the inverse function G inverse. So how do we do it? We first let y equals to x squared plus 6x. So y equals to x squared plus 6x. Okay, then what we want is to make x the subject. Okay, so we do this. Why do we do this? Because we want to complete the square. So this is how you complete the square. So x squared plus 6, right? So to complete the square, to write it in something like that, I need to add 9, because this x squared plus 6x plus 9 is equals to x plus 3 square, right? So, and then because I added a 9 here, I have to minus 9. So I have this minus 9 over here. Okay. Then I'm getting there to making x the subject. If I bring 9 over, it's plus. If I square root it, I get this. And then I bring minus 3 over, I get this. Therefore, G inverse, so since they want it in this form, x, right, I need to change my variables. Instead of y, I need to change it to x. So this is the final answer. Okay. Right. The next one, question 20. So this is the question on probability. Okay. So we're given that this bowl have n pieces of fruit. Okay. 4 of them are oranges, then the rest are apples. So this immediately you have to you must see that the number of apples is n minus 4, because 4 oranges, so therefore the rest are apples, means n minus 4 is the number of apples. Okay, then 2 pieces of fruit are going to be taken out at random, so there'll be 2 pieces of fruit taken out, and do note that nothing is being replaced back. So each time something is taken out, it's minus 1. 1 is being reduced, right? There's 1 less in the bowl. Okay, so the probability that the bowl will then contain n minus 6 apples is 1/3, right? So from this, the probability that the bowl will contain n minus 6. So n minus 6, immediately you can see that n minus 6 is from n minus 4 minus 2. So this means that originally you have n minus 4, and then after you took 2 apples, right, the probability is 1/3. So therefore this means that, right, 2 apples have been picked out, and then the probability that 2 apples have been picked out is 1/3. Okay, so I can form a formula like that. So n minus 4 over n is when my first pick. So this is my first pick. Okay, then because my next pick, I have 1 less apple and then 1 less fruit, so I have n minus 5 over n minus 1. Okay, multiply. So this is equals to 1/3. Okay, then from there, I want to find n from this equation. So I need to simplify. So this question is not so easy because we need to simplify it. So I rewrite it as this. Okay, then I expand it. So n minus 5 minus 4, n minus 5. Okay, then n square minus n. Okay, then I expand this. So I get n square minus 5n minus 4n plus 20. Okay, so here and n square. So I can rewrite this as this. Yeah. Okay, pretty simplified. Then I'll follow by a cross multiplication. Okay, which gives me this, and then I'll expand this. Okay, this is very tedious. But as you can see, I'm trying to get a quadratic equation here, right? So I get 3n squared minus 27 plus 60 minus n squared plus n. Then I simplify even more. 3n minus n squared, 3n squared minus n squared, 2n, minus 27n plus n minus 26 plus 60. Okay, divide by 2 throughout, n squared minus 13n plus 30, and I get this. And I got two answers, n equals to 10 or n equals to 3. We can't have two answers, right? But it's quite obvious because since there are 4 oranges, so therefore we have to reject n equals to 3 because there are more than 3 fruits, right? Okay, so final answer is n equals to 10. Okay, last question. 2x plus 23, 8x plus 2, 20x minus 52 are 3 consecutive terms, right? Consecutive terms of an arithmetic sequence. So what does it mean by 3 consecutive terms of an arithmetic sequence? So 1, 2, 3 are 3 consecutive terms. 2, 4, 6 are consecutive terms of an arithmetic sequence. Okay, so from this you can see that that's increased by 2, increased by 2, right? Increased by 1, increased by 1. So this is an arithmetic sequence, right? So the question is asking us to prove that the common difference of the sequence is 12. Okay, fine. So let's name the term 1, 2, and 3. Okay, so let's find the difference between this term and this term. So we need to take the bigger term minus the smaller term. So this gives us 6x minus 21. And this one, bigger term minus the smaller term, I get 12x minus 54. So assuming that these two have common difference, right? They have the same common difference. These two differences are the same. So we put 6x minus 21 equals to 12x minus 54. Then we find x. Okay. Then we use this x equals to 5.5 to find T1, T2, T3. So we substitute 5.5 back in here, and back in here. So we get T1 as 34, T2 as 46, T3 as 58. Okay, so then here you realize that yes, T2 minus T1 equals to 46 minus 34 equals to 12, right? So the common difference is 12. T3 minus T2 equals to 12 as well, right? So therefore, we prove that the common difference is equals to 12. Okay, so this is the end of the paper. I hope you like it. Please like and subscribe. I'll see you next